Okay, hello everyone. Good afternoon, good evening, good morning, wherever you are. Um, my name is Mina Naziri, and thank you so much for being here. So this is our Spotlight series, where we talk about different, programs within the Viterbi School of Engineering. And today we're highlighting Aerospace and Mechanical Engineering. And with us, we have Professor Paul Ronney, who'll be giving us a lot of insight into the Aerospace and Mechanical Engineering Department and our master's programs that we have here at Viterbi. So thank you so much for being here, Professor. I'm excited to get started. So just some quick housekeeping. We will be following up in a couple of business days. So you will have a copy of the slides from tonight's presentation. So there's no need to jot anything down immediately. So throughout the presentation, if you have any questions, please go ahead and chat them in using the chat function or the Q&A function. I'll be monitoring both, and then I'll answer them at the end, along with Professor Ronney at the end when we have time for a Q&A. So tonight's program will be about the USC Viterbi School of Engineering, for those of you who haven't joined me at a previous webinar, and then our master's programs in Aerospace and Mechanical Engineering and some of our frequently asked questions about these programs. I'll also talk about Done at Viterbi, which is our online delivery method. And then at the end of the session, we'll have some time to answer some questions you might have for myself or Professor Ronney at the end. So just an overview of the University of Southern California. Again, for those of you who haven't joined us at a previous session, we are the oldest private university in the Western United States. We were founded back in 1880. Currently, we have over 47,000 students with over 26,000 graduates, 26,000 graduates. We have over 4,700 full-time faculty, which includes our adjunct faculty. These are faculty members coming from a variety of different industries, and we also have a very diverse student population, representing all different backgrounds and walks of life and locations around the world. For those of you who are not familiar with the LA area, we are located roughly a 15 to 20-minute drive from downtown LA, obviously depending on our notorious traffic. So this is just an overview of the Viterbi School. The Viterbi School specifically has 8 academic departments. We have over 6,800 graduate students as of last fall. These are made up of our master's students, both on campus and online, as well as our doctoral students. In terms of our faculty, we have 213 tenure track faculty, 16 full-time, and 34 total TTNAE members. We have also over 90 recipients of the National Science Foundation Career, National, and Presidential Young Investigator Award. Also alongside faculty, of course, comes research. USC Viterbi is a leader in funded research. We have over 35 research centers, a majority of which are located here in Southern California. We also invest over $177 million on an annual basis into our research. And this is great because our faculty members, with the support of their doctoral students, they conduct a lot of research that is then published and then reincorporated back into the curriculum for our grad students to learn from. So I'm very happy to introduce you all today to Professor Ronney. He is a professor and chairman of the Department of Aerospace and Mechanical Engineering. He earned his bachelor's in mechanical engineering from UC Berkeley, go Bears, his master's in aeronautics from Caltech, his doctorate in aeronautics and astronautics from MIT as well. His experiments have, flown on 3 space shuttle missions, and he has published over 80 technical papers, made over 250 technical presentations, and holds 7 US patents. He is a fellow of the American Society of Mechanical Engineers, as well as the Combustion Institute. And lastly, he is an associate fellow of the American Institute of Aeronautics and Astronautics, and a recipient of the National Science Foundation Career Award and Combustion Institute Distinguished Peer Award. So I will hand it off to you, Professor. Thank you so much for joining again. And I will also unmute you. Oh, you are already unmute. Beautiful.
Yeah. Okay, great. Well, thank you so much. First, thank you all for taking the time to attend this. We hope to see you in the fall or whenever you would be attending here. First of all, let me talk about the major research themes we have in our department, Aerospace and Mechanical Engineering. We have robotics and autonomous systems. We have some faculty that are real experts in the field of robotics. Energy and sustainability, which is my field in particular. Design and manufacturing. We have an outstanding, what we call Center for Advanced Manufacturing, which is just off campus. and we have a number of faculty that are really superstars in that area, as well as medicine and bioengineering. We have a number of faculty involved in sort of the mechanical engineering aspects of medicine. And we also particularly focus on artificial intelligence and machine learning, as well as the aerospace. Notice there's a lot of MAE departments, mechanical and aerospace engineering. There's not very many AME departments, as in aerospace and mechanical engineering, if I said that right. Um, and so we do have a lot of emphasis, considering where we are in Southern California, the center of the world's aerospace industry. That's a key feature of our program. Um, Let me see if there's anything else I wanted to say about this. No, I guess not. Okay, so we have, I think that's it. Okay, go ahead. All right, so we have 36 full-time faculty. Actually, I think it's 35 right now, but in January it'll be 37 as we get to. So there'll be 27 tenure track as well as 10 teaching track faculty, and a number of joint appointments. And right now there are actually 10 teaching or practice faculty. And we have, on the order of 500 undergraduates and 500 master's students and 100 PhD students, and a significant external research funding base for our research. I also mentioned these student groups. Now, of course, these student groups are typically focused on the undergraduates, but however, master's students in most of them, most if not all of these master's students are. There's some I have to be careful because PhD students are not allowed to participate in some of these, depending on the rules of the organization that sponsors the contest. But I know that master's students can participate, I think, in all of these teams shown here. We have a Formula SAE Society of Automotive Engineers. So we build a Formula race car every year from scratch, basically, and then compete against other universities. The last few years, the competition has been in Michigan. So we ship the students and all of the vehicle and all the support equipment to Michigan, as well as our aero design team. And they've actually been extremely so. Basically, every year they have to build a new airplane. It's a radio-controlled, electric-powered aircraft, which then competes against again other teams. And actually, we've been extremely successful in this team. We've won actually the national championship 3 of the last 10 years. I always tell our dean of engineering when I ask for support for the team, now, what if our football team had won the national championship 3 of the last 10 years? You give the coach anything coach wanted, right? Well, these people are pick the Alabama, Michigan, Georgia, whatever, if you will, of this particular competition. So, and we're not asking for millions, we're asking for a few thousand here and there. Anyway, so we have a number of other teams, um, including our human powered vehicle team and the advanced spacecraft propulsion team. Um, and so we have a lot of opportunities for you to do these outside extracurricular activities. They're not part of our curriculum per se, but there's a lot of opportunities to get involved. And I can tell you from experience that if you go for job interviews and you say, well, I worked on on the advanced spacecraft propulsion energy team, they're not going to ask about what you learned in my class. They're going to ask you about what you did on one of these teams. What were your projects? What problems did you run into? How did you solve them? How well did you do in the end, et cetera, et cetera. And okay, next slide. And so we have a lot of master's programs. We have a lot of specialties. We have just sort of the generic master's in aerospace engineering or mechanical engineering. And then you see we have a number of those. I'm certainly not going to go through all of these. But if you prefer to have a specialty, then you're more than welcome to do so. You see we have a lot of individual programs. And we have faculty that have strengths in all of these areas so we can support I think a fairly rigorous program in any of these areas. And I'm the department chair, and one thing we're trying to do is get more hands-on experiences for our master's students. Now, we have a lot for the undergraduate students, but typically I think you'll find at most master's programs, it's often just strictly coursework. There are no hands-on activities. Like we have a number of classes where you can either, build robots or we're starting one this coming summer. We're going to pilot it to see if we can have a graduate version of our undergraduate course that we call Mech Optronics. That's a handful, but basically it's a course in measurement and instrumentation. And we think this is a very valuable skill to have. And all of our undergraduates go through it, and it's a big part of their curriculum, and that makes them very marketable to the local industries. And we're introducing a graduate version of that, so you can learn how to, how to do measurements, how to collect data, how to interpret data, how to present data. And we're trying to do that at the graduate level, as we have for many years at the undergraduate level. And then you see some of these programs now, go back for just a second. Some of them involve things that aren't strictly aerospace or mechanical engineering. For example, this dual degree with engineering management. Again, either on the aerospace or the mechanical engineering side. Okay, next. And so the requirements are fairly simple, 27 units. You have to take one of the math courses. There's actually a new course. So AME 525 is essentially a linear algebra course. 526 is a partial differential equations course. We also have a new one, 540, which is basically probability and statistics and some aspects of machine learning. So that one may be more useful depending on what your interests are. And again, the remaining 27 units, so that's four units right there for the math class. And then the remaining 27 units can be from, an approved list of either 500 level, that is graduate courses, or 400 level, which is senior level undergraduate courses. And we have quite a few interesting senior courses, and I believe you can take up to 8 units at the 400, that is senior undergraduate level, and the rest have to be at the graduate level. And again, you have a lot of freedom. They don't all have to be aerospace and mechanical engineering courses, the 500, 400, 500 level courses. I believe besides the math course, I think it's 15 units have to be within our department. But then that gives you a lot of flexibility if you want to take courses in other engineering departments, or even, science or math courses outside of the School of Engineering. And then again, we have a number of these specialties that we discussed before. Okay, go ahead. Okay, and here's just one example. Is obviously computations, are becoming more and more part of what we do. That is, just even like in my freshman class, of course, you're not here for undergraduate studies, but I just happen to have a prop here, so I had to show it. So how do we design and build anything nowadays? We don't just sort of, start cutting metal and see what happens. What we do typically is, okay, we have a set of specifications, we brainstorm ideas, we draw up our ideas in using CAD, computer-aided design software, for example, SolidWorks or NX or AutoCAD, and then we test it virtually. Once we have what's something that kind of looks good, then we test it virtually. We do some simulations before we ever build a piece of hardware. In this case, in my freshman class, what we do is one of the projects is to build a 3D printed bridge. And so they learn how to not just draw this with computer-aided design, but also how to test it, virtually apply a load to it and see where the stresses are, and then try to build one that can hold the most load before it actually fails. And it's only after that, after doing the simulation, that's what's really different about engineering now compared to even 20 years ago, is that you do a lot of simulation, whether it's structural or thermal or hydraulic, aerodynamic, electrical, whatever. There's a lot of simulation that goes into your design before you actually ever create a physical part. And in this case, the part is, and a lot of parts nowadays are 3D printed. We have a very popular set of courses on 3D printing. And so then once you 3D print it, only then do you actually test the physical structure. And we do that in my freshman class. So this particular example of one of the things we do is computational fluid and solid mechanics, which again, a lot of the engineers nowadays will be doing this sort of thing because it's so much cheaper to, as long as you have high fidelity models, it's so much cheaper than to test all these things virtually before you test them physically. Of course, eventually you're going to have to do the physical testing. You can't rely entirely on what the computational predictions are, but it saves you a lot of and makes the design cycle go much faster if you do this computational part. And so again, you can see these are the required courses for that. And I think, yeah, okay, that's enough. All right. And then we have some others, dynamics control. Some of you might be wondering, well, what does it mean? What is control actually? The way I like to describe it here is, okay, let's see, I have this rocket here. That's maybe not the best. Let's imagine that this is my rocket. Now, I can satisfy all the laws of mechanics with this rocket balanced on its point there. But you see, yes, so it is an equilibrium condition, but it's an unstable equilibrium. So we need a control system to make it stable, to stabilize this inherently unstable system. I happen to have a rocket model here. But so a lot of what we do, as engineers involves controlling what is something that is like modern high performance aircraft are actually not controllable by any pilot. Not even the best pilot in the world can control it. It's only with the control systems that are built into the aircraft that the aircraft becomes stable. And so that's what we talk about when we talk about control systems. And again, so we have a number of these types of programs for you, depending on your interests. Okay, next one. All right, energy conversion. See, so you can take, again, in this one, this is now getting towards my specialty, is we do combustion. People say, "Oh, isn't combustion obsolete? Aren't we going to stop burning fossil fuels, next year or 5 years from now?" Well, still to this day, 75 or 80% of our energy is produced from the combustion of fossil fuels. So the question is, how do we make it as efficiently as possible, use the least, produce the least amount of carbon emissions possible, and also how do we make it as clean as possible with as few pollutants as possible? And so that's what you learn about here, in addition to, as you can see then, alternative energy. So we like to, consider both ways. We're always interested in this, what was so-called energy transition away from fossil fuels. And in fact, where we've done a really good job is in the area of electrical power generation, which used to be a large part of it was from coal. Nowadays we burn a lot more natural gas, still a fossil fuel, but it only produces half as much carbon emissions for the same amount of energy produced. So that's really reduced our total carbon emissions. And we have more and more wind and solar uh, coming online, and nuclear even may come back. I mean, nuclear is really good. There are issues with it, of course, but it's actually, a great carbon-free source in many ways. Okay, next. Okay, so we have a bunch of these. So maybe so we can get to the Q&A. I think people have the idea here. Why don't we just move on? Because I want to get to the Q&A. Okay. Okay, so dual degree. Well, we should talk about at least dual degree programs. So again, we have this dual degree in aerospace engineering plus engineering management. And you can see now this is a much more extensive program because now it involves taking courses not just in AME, but also in industrial and systems engineering, which you could take one or two classes already in industrial and systems engineering without being part of this. But if you do this full dual degree program, notice now it takes 48 units instead of just 27 units to get the degree. But now you're going to get two master's degrees and not just one. Okay, next. Okay, so then you say, well, all right, great. I sign up, I take the classes, I get my diploma. What's next? So, all right, this is an animated slide, so you'll have to advance it.
Oh,
Oh, yeah. So
there
the
we go.
largest, yeah, okay. So the largest employer of our both undergraduates and master's students is Boeing. Second largest, again, under bachelor's and master's, is Northrop Grumman. But you can see there's a lot of other places that they go. Obviously, a lot of our students go to both a small and large aerospace companies in the area, SpaceX or Blue Origin, Virgin Galactic, Relativity Space. I could go on and on and on about those. We have a lot of students go to JPL, the Jet Propulsion Lab. We have Air Force bases around here, and you can see a wide range of aerospace companies. And you see some students, go into other aspects. Like I noticed that legal is there, which is interesting because for undergraduates, not for masters, but for undergraduate students, my two best students ever, both of them were in three of my classes. Both of them not only got the best grade in the class in all three classes, but actually just blew the top off the curve in all three of those classes. Both of them now are patent attorneys. So, there's certainly a big market, especially in, the intellectual property field as it is today, a big market for patent attorneys, as well as, another student of mine. This is one of my proudest student stories. Is that I had a student in my freshman class who admitted to me she was not only the first person in her family to go to college, she was the first person in her family to graduate from high school. She was Latina from the local area and came to USC on what's called a Norman Topping Scholarship. It's a scholarship fund set aside for students from the local area who otherwise could not afford to attend USC. And she got through the program, got her bachelor's and her master's here, and now is a consultant with a major consulting firm in the Bay Area. Probably makes more money than I do, but hey, that's fine. Okay, go ahead. Yeah, and also, I guess you see also the music and the movie industry. That's one of the nice perks about being in this area, is we get to work with the entertainment and the news media. I actually have a page on, if you're familiar with IMDb, the Internet Movie Database. I actually have a page there. I've been on a number of TV shows, just as an expert talking about the things that I know about space, about energy. In fact, my sort of, my best role was on an episode of Modern Marvels on engines, where I explained what's the difference between a piston cylinder type engine like you have in your car and a jet engine that you see in most aircraft. Why is the jet engine so much more powerful for a given size or weight of engine? And I explained it like this. Imagine that you're baking cookies. You put blobs of cookie dough on the cookie sheet, you put it in the oven, and then you wait. Then when they're baked, you take it out, you dump them out, and you repeat again and again and again. That's like a piston cylinder engine. Now compare that to if you put blobs of cookie dough on a conveyor belt and go straight through the oven. That's basically what a jet engine or gas turbine does. So it's a continuous flow process instead of a constant stop-start. So you can process a lot more air per unit time in the case of the jet engine because it's not stopping and starting all the time. So I don't know that episode has been cut and recut, many, many times, but that part always gets, I guess the producers like that analogy. But in case there, and some of our faculty have Emmys and Oscars for their technical contributions.
Oh, beautiful. I will jump in here. Thank you very much, Professor. I learned a lot. So
I
I
hope you,
will,
I hope you listen hard. There'll be a quiz on Tuesday.
beautiful. I'm ready. But yeah, I will talk now about our online offerings. As Professor Ronney already mentioned, we have a number of programs that are available online via our online delivery method, which is called Dennett Viterbi. This includes our master's programs in aerospace engineering, mechanical engineering, computational fluid and solid mechanics, dynamics and control, energy conversion, product development and engineering. And then we offer two dual degrees, the aerospace engineering and engineering management dual degree, as well as the mechanical engineering and engineering management dual degree that Professor Rani touched on earlier. So in terms of our delivery methods, all programs, of course, are available on campus, and a large majority of on-campus students tend to be taking courses full-time, but this is definitely not a requirement. It also depends on your goals in terms of how soon you want to complete your program. But typically on-campus students are taking anywhere from 2 to 3 courses at one time. And so they usually graduate within one and a half to 2 years. Typically, students who choose to take summer courses will finish on the earlier side of that 1.5 to 2 years. And in terms of our online delivery, a large majority of our online Dennett Viterbi students are actually working professionals. So we actually don't recommend that you take more than 1 or 2 courses at one time, given that you're working 40 plus hours a week. So a lot of our Dennett Viterbi students are taking 1 to 2 courses. at one time. But you definitely don't need to be a working professional to be a Dennett-Viterbi student. We have some students who are just in a different location outside of LA or even California who just want to study full time and get a degree from USC. So that's possible too, of course. So on average, given all of this, our Dennett-Viterbi students tend to be graduating within 2.5 to 3 years, given the decreased course load each semester. But everybody has up to 5 years to finish their degree programs, and you can even petition for an extra 2 years if you need it. So how does Dennett-Viterbi work? So this is the Viterbi School of Engineering's state-of-the-art proprietary web-based delivery system, and it enables students from all over the world to access their classes in two ways. You can watch live by streaming in, or you can watch on demand afterwards as a recording. So Dennett-Viterbi students do also have a physical seat in each of their classes that they're enrolled in. You're viewing the same lectures with the same faculty as on-campus students, and the content is fresh every single semester. So you're able to participate in interactive discussions with your peers and your instructors, and you'll submit your homework electronically. Though you will take your exams at a proctored location, either near your home or your work. However, if you live in Los Angeles, Orange, or Ventura counties, you will be taking your exams here at USC on campus. So this slide just shows the comparison between a Dennett-Viterbi student and an on-campus student. So the program admission requirements are exactly the same. So you're submitting the same graduate application with the same accompanying materials, such as your personal statement and letters of recommendation. Weekly course lectures are online with interactivity for Den students, but of course, as an on-campus student, you'll be attending in person. Um, Den students will have access to course archives and documents and lecture recordings, and on-campus students only have this privilege if they're enrolled in a Den course. Assignments for Den students are submitted electronically, but the deadlines are the same across both delivery methods. And again, if you're residing in Los Angeles, Orange, or Ventura counties, you'll need to take your exams here at USC on campus. In terms of courses per semester, it really varies. If you're a working professional, we typically, again, don't recommend taking more than 2 courses at a time. So the degree completion requirements are the same and they vary by program. So all of our programs hover between 27 and 37 units. And then all Viterbi graduate programs require students to maintain at least a 3.0 GPA. And then at the end of it, when you're done with all your hard work, the diploma is exactly the same, regardless of your delivery method. So if you are an online Dennett-Viterbi student, there is nothing on your diploma that would, distinguish or give away that you did your degree online. So what are the application requirements and tuition and fees? So our general application criteria for master's programs are an undergraduate degree in engineering, math, or a hard science from a regionally accredited university. And then to be competitive, an undergraduate GPA of at least a 3.0 is recommended, though even if you have under that, the only program at USC Viterbi that requires this 3.0 GPA is astronautical engineering. So don't be discouraged if your GPA is slightly under 3.0. Some wonderful news is that the GRE is not required for the 2025 admissions cycle. So that's wonderful. And you'll also need to submit a resume, a personal statement, and then depending on your program of interest, a letter or letters of recommendation. And then for our international applicants, you will need to also submit your English proficiency exam scores. It's important to know that every program has unique application requirements. For example, how many letters of recommendation you'll need to submit. So make sure to check out our website for the most current information and information specific to your program of interest. And the link there is going to be at the bottom. So for those of you interested in admission for spring 2025 and classes begin in January, the application deadline was on September 1st, but an application extension can be granted on a case-by-case basis for those of you who are interested in pursuing your degree online through Dennett-Viterbi. And this is for students who do not require a visa sponsorship, such as an F1 or an I-20. So if you want to get started in January, you can reach out to us by email at dennetviterbi.usc.edu and we'll be able to give you more information on how to receive this application deadline extension. But if you're interested in starting in the fall of next year, the application deadline will be on December 15th. So this is just some additional information. So for prospective Janet Viterbi students that are wanting to get a jump start on taking classes as soon as this coming spring without having to go through the formal admissions process, this can be done via limited status enrollment. And this option does require that you have an undergraduate degree in engineering, math, or a hard science or a related field with a cumulative GPA of at least a 3.0. And it's limited in the sense that there's a maximum of 12 units that you're able to take before you stop or apply for formal admission. Um, it's also important to note that this does not guarantee that you will be admitted later when you apply. But if you want to get started taking classes before formally applying, you just need to complete what's called the Dennett Viterbi profile, which is a super quick process. You can do this up to a week before the semester begins. And then we also offer something called employee reimbursement deferment. And this is for students whose companies will reimburse them for their tuition at the end of the semester. Um, rather than having to pay out of pocket, you can defer your payment of up to 90% of your tuition up until the end of the term. So in order to be eligible, your employer needs to reimburse you for tuition and your student account needs to be current. And you can take a look at the additional requirements at the bottom of this slide and as well as at the link at the bottom. I know some people joined us a little bit into this webinar, so no need to jot everything down. I will send you these slides in a couple of days. So no need to scramble to write this all down. So do we offer any scholarships or funding? Yes, we do. So for Dennett Viterbi students, we do have a Dennett Viterbi scholarship. This is merit-based and awarded to outstanding students who are pursuing a master's degree online through Dennett Viterbi. It's a partial scholarship and it ranges between 1 and 4 units for those of you who are receiving either partial or no tuition reimbursement help from your employer. It has to be used within the academic year that it's awarded, and you can reapply every single year. So to be eligible, you do need to have at least a 3.0 as an incoming student from your undergraduate GPA, or if you're a continuing student, a 3.3. And then the spring 2025 application is going to be on November 15th. All right, this slide has a few of the things I touched on in this webinar. So to get started, you're welcome to visit our lovely campus. And same thing goes for you, for those of you who are interested in pursuing your degree online through Dennett Viterbi. We have virtual and in-person tours. And whether you're planning to be an on-campus or a Dennett Viterbi student, you can get started with your application for formal admission. Again, we can offer an application extension for those of you who want to get started this spring online. And if you want to get started in the spring without going through the admissions process yet, you can complete your Dennett Viterbi profile to get started as a limited status student. All right, on to the Q&A. So we'll open the floor to all of you. I know some questions came in, so I'll read them out loud. Let's see. So some of you use the Q&A and the chat function, so I'll go through both. So I'll start with the chat. So um, let's see. So we have one attendee who says, I'm particularly interested in the automotive industry and was wondering if USC's mechanical engineering department offers specializations in areas like transportation, electric, and autonomous vehicles. Could you also share some information about the rate at which MS students are typically securing research assistantships? Oh, you are muted. Let me.
Yeah, on WebEx, I didn't realize I can't unmute myself.
Yeah.
Yeah. Anyway, yeah, thank you, Sam from Ghana. I haven't been to Ghana, but I've been to Liberia and Ivory Coast nearby. So anyway, about your question about the automotive industry, so we have a number of courses in, like I say, combustion. I teach a senior level course, which again is a course that you could take as a master's student on automotive engines and gas turbines. In fact, if you want to shoot me an email, I can give you access to the lecture slides, just so you'll see what's in that class. And you might also, if you were to come here, I don't know if you were planning on coming here from Ghana or if you would be participating remotely, but if you were coming to be here in person, you could join the Formula SAE team. You saw earlier Formula SAE, and we have both. You mentioned combustion and electric. We have both teams. We have both a Formula SAE internal combustion engine team and an electric team. So you can join either one of those. And those are, I'm 99% sure open to master's students as well as undergraduates. And in terms of autonomy, we have a number of courses, and that number is always growing in terms of autonomous systems, which is, of course, a big thing nowadays. Let's see what else is in your email. Okay. Oh, research assistantships. Okay. Well, there's the bad news is that research assistantships are essentially only open to PhD students, not to master's students. Now, it's possible you could get hired to work on an hourly basis. See, when we talk about research assistantships, these are students who are fully funded. They get their tuition paid, they get all their fees paid, they get a stipend. It's not a huge stipend, but it's enough to live on, at least very modestly in Southern California. But that's only for PhD students. For master's students, you can be paid hourly uh, to work in a faculty member's research lab by agreement with that faculty member, but not the more lucrative research assistantships. That's not available to master's students, only PhD students. You applied for spring semester in controls and dynamics. You'd like to transition to the PhD. What are the steps? Oh, okay. So good question. In fact, Masters, our master's program is our best source of PhD students. Probably about half of our PhD students come originally as master's students. And then what happens is if they do well, if they, about half of my PhD students start out as master's students. So they'll be in a class of mine. And then at some point they'll say, I like this material. Could I work in your lab? And if I think the student's capable, I will, give them some small project to do in my lab. If it does well, and if that's something they like doing, it's a two-way thing. And so if it works well from both perspectives, then I'll encourage him or her to apply for a PhD, and then they can become my PhD student. And a lot of our faculty work that way. So it's actually a very good way of getting into the PhD program. Excuse me, because you see that it is it's a big gamble for us to take PhD students directly from undergraduate because we're committing, if we take you on as a PhD student, we are committing to supporting you fully for at least 4 years. So it's a big commitment. And something like this, if you do a master's here, that makes us a lot more comfortable with making that commitment.
Beautiful. And then we also had a question come in through the Q&A. Currently working full-time and interested in applying for a den at Viterbi. Are there opportunities for students who live nearby to join in on projects on campus?
To join in what on campus?
Join projects on campus.
Oh, yeah. Yeah, if you live, I mean, just because you're officially a Den student, there's no reason you can't come to campus. In fact, I've had in the past Den students who, it's interesting, I have students who try to go both ways. I have Den students who come to campus, even had like, foreign students say, well, I'm sort of, in the online section, but for my visa and all that, or they're in the in-person section, but they're actually participating remotely in the online section because they're somewhere else. And we've had students go the other way, where they are in the on-campus, I said that right? Yeah, they're in the den section, but they come to campus for lectures. You know, so um, so yeah, there's plenty of opportunity. There's nothing that says if you're a Den student you couldn't join, Formula SAE or Aero Design Team or one of those. If you're there, the one thing I will say, a question I get asked is, well, how do I participate in one of these project design teams? And basically the answer is do the work. You're not going to go very far if you just come in and come in 1 hour, 2 hours a week. But if you go there, you show interest, you get your hands dirty and you actually do the work. That's how you sort of build up to a more senior position of responsibility in those teams. Again, they tend to be organized primarily around undergraduate students, but again, there's no reason that master's students can't get involved. And there is one other team that is actually largely masters and PhD students, and that's the liquid propulsion lab. So we have a team that builds liquid oxygen kerosene rocket motors, and that's at least 50% graduate students. They don't participate in any particular design competition, unlike the Formula SAE or the aero design team, that they go to um, a formal competition every year. But still, they actually do go out to the Mojave Desert and actually light off their rockets.
Wow. I also want to add that, as a Dennett Viterbi student, you are all of the resources available to an on-campus student are also available to you. So, you also, I think I mentioned this before, you also have a physical seat in all of your classes. So, as in person as you would like to be, that option is always available to you. And then we also received another question. I'm interested in the mechanical engineering slash engineering management dual degree. Also looking to jobs for next fall. Can I apply for the full-time in-person program, but change if I decide to pursue a job and study part-time? The answer is absolutely. So, if your circumstances change and, your job, you get a job, which if you do, congratulations, that would be wonderful. You can absolutely reach out to us and we can change your delivery method. Um, so, whatever delivery method you decide to, begin your degree in, of course, if your circumstances change, this even applies to those who, if their circumstances move them out of the city and they want to continue their degree, they can transfer to Dennett Viterbi. So just email us at dennetviterbi.usc.edu, and then we can go ahead and get the process started on changing your delivery method. So that's always an option to you. And then I can allow some more time for any extra questions that might come through. But also if you have something more personalized that you don't want to pop in the chat for everyone to see, you can always schedule a call with us. So when I follow up with you with the slides in the next couple of days, there will be a link in there if you want to schedule a call with myself and my colleague Marilyn, and we can discuss your background and all of that good stuff. So I'll allow a few extra minutes for any questions, any last minute questions, but thank you so much. Oh, we have one. Um, let's see. Is there flexibility to start off in the aerospace master's program and then switching to one of the AME specializations such as computational fluid and solid mechanics or the dual degree program? So how easy is it to switch programs?
Yeah, sure. As long as now, if you, depending on what courses you've taken, then if you really want to follow that specialization, that might require you to take some additional courses beyond the 27 or however many units to be able to follow that. But no, there's nothing, there's no there's no restriction on switching, between these. It's not like you're switching from aerospace engineering to art history or something like that. So it's all within AME, so that we can do quite readily.
Wonderful.
Well, let's see. There's another question here. Will there be a chance to chat with anyone from the computational fluid and solid mechanics program um, on November 1st? We could probably arrange that. Um, what I would suggest is, um, is just send us an email or something, and maybe I can set something up with, through our student affairs staff within AME to make that possible.
Beautiful. And for those who don't know what November 1st is, November 1st is USC's preview day. So for any prospective students who want to join us on campus if you're around, or you can also join the Dennett Viterbi session virtually, to learn more about the USC experience. I invite you all to join us on November 1st.
Oh yeah, I think I'm involved in that too, aren't I? Oh yeah. Oh yeah. Yeah. I see 10 o'clock. Okay, on that morning, I see.
Amazing. Yeah, the Dennett Viterbi session will be it'll be at 1 p.m. So you'll get a tour as well of the a Dennett Viterbi classroom, so you can see where the moderator sits and super fun. So, oh, we have another question. Does the graduate admission office or mechanical engineering department offer application fee waivers to prospective applicants? So there are a number of application fee waivers available. We offer, for example, a second application fee waiver. So if you're applying to more than one program, you can, apply to both programs for the price of one. So we do have a page that lists all of our available fee waivers. If you can't find it, just email us at dennetviterbi.usc.edu, and I can send that link to you as well. So there are a number of fee waivers that are available. right. Any additional questions? Okay. Well, thank you so much, Professor, for your time. And this was, I learned so much. So thank you so much. And you know, for all of you who are attending live, thank you for being here. And if you're watching this as a recording, wherever you are, good night, good afternoon, good morning. And as we say at USC, fight on.
Yeah, and I hope to see some of you in the fall.
Yes, I'm echoing that. And also, I will share the link to schedule a meeting with me in our follow-up communications. I see your question in the chat. But yes, thank you all for being here. Have a wonderful evening.
All
And
right.
thank you, Professor Ronney. Bye-bye.